Derivatives of trig functions. Consider the function f of x equals sine of x. And we want to find its derivative, f prime of x. I'm going to start intuitively, and then I'll show you an algebraic proof of it. So, to do this, kind of the intuition of it, you're going to have to accept a fact, if you don't mind, that the slope of sine x at x equals 0 is 1. So in this bottom graph, I'm going to plot points that give the value of the slope. So when x equals 0, the slope is 1, so I'll plot 1 up there. Now at pi over 2, the slope of my graph sine of x is 0, because I have a horizontal tangent line. So I'm going to plot the value of 0 on my slope graph. I think you get the idea of what I'm doing here. Over here, by symmetry, if you can accept that the slope here is 1, then the slope over here, hopefully you can accept, is negative 1. So I'll plot the value of the slope here at about negative 1. At 3 pi over 2, the slope is 0, and at 2 pi, we're back to 1. Now, I need to connect these dots somehow, and I could do a straight line, but it doesn't really make sense because my original graph is curved, and certainly if I plotted more points, we would see what happens, that I need to connect these dots in a curved fashion like this. And if you know your graphs well, you would recognize that the graph of the derivative is the cosine of x. Let's do the algebraic proof. Just to show you that it's true, where we're going to do the limit as h goes to 0 of what? Well, f of x plus h, so sine of x plus h, minus f of x, or sine of x, all over h. This is the definition of the derivative. So this will give me the derivative of sine x. We're going to need to use a little bit of trig here going forward. So the limit as h goes to 0 of, and then we're going to expand this part here, which is the sine of x times the cosine of h, and then we get plus cosine of x times sine of h, minus the sine of x all over h. This is a trig identity. This is the addition rule when we have sine of like a plus b. Gives us that expansion. So I'm just going to rearrange this in a way that hopefully will help us. So I'll write the limit as h goes to 0. And then I'm going to put my sine x's together. It's like this. So sine x, see if I can skip this step, where we have the sine of x times cosine of h minus 1. So I combine these two parts and then factored out the sine of x. And then the back part I have plus cosine of x times sine h. Algebra says I can split up a numerator and I still have h over each part, like this. Now, when we were doing limits, we saw that the limit as h goes to 0 of cosine h minus 1 over h is 0. And the limit as h goes to 0 of sine h over h is 1, which leaves us with cosine of x. So the derivative of sine of x is cosine of x. Let's do the intuition again, where f of x equals cosine of x, and we'll plot values of the slope down here. So I want to find what f prime is, or take a good guess at it. So when x equals 0, the graph of cosine have a slope of 0, so I'll plot the value of 0 down here. Remember, this bottom graph, we're plotting values of the slope. At pi over 2, the slope is going to be -1, so I'll plot about right there. At pi, the slope is 0, so I'll plot the value of 0. At 3 pi over 2, the slope of cosine have a value of 1, and then back to 0. Once again, I need to connect the dots, and because my graph up here is curved, it makes sense that I would connect them with a curve over here. And notice that the derivative is not sine of x, which I might have thought. It's the negative sine of x. Let's see if we can come up with that algebraically. Let's do the algebraic proof on this. So we want to find the limit as h goes to 0 of f of x plus h, so cosine of x plus h, minus f of x, or cosine of x, all over h. We will need to use a trig identity again, so the limit as h goes to 0. And if we expand this one, we get the cosine of x times the cosine of h, and it's minus sine x times sine h. That's the expansion, and now we have a minus cosine of x left over, and all over h. Rearranging some stuff, we get the limit as h goes to 0. And then I'm going to put these two terms together and factor out the cosine of x. So the cosine of x times cosine of h minus 1. Convince yourself that's what I did. All over h. And then minus sine x times sine h over h. Once again, the limit as h goes to 0 of cosine h minus 1 over h is 0. As h goes to 0, sine h over h is 1. So we're left with negative sine x. Very briefly, let's look at the derivatives of these 6 trig functions. So the derivative of sine is cosine. The derivative of cosine is negative sine. And watch what happens here. So the bottom 4 we could prove, but in a different way when we have some more techniques. For now, I just want you to memorize these answers. But the derivative of tangent x is the secant squared x. The derivative of cotangent x is negative cosecant squared x. Well, how about the derivative of secant? Well, the derivative of secant is secant x times tan x. What do you think the derivative of the cosecant of x is? If you look above, you can see some sort of symmetry or anti-symmetry going on. If you guess negative, you're on the right track. Notice how the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So if the derivative of secant is secant tan, then the derivative of cosecant is negative cosecant cotan. And those are the derivatives of the 6 trig functions.